This tutorial talks about what I call the no-join method in SQL Server. This is when you have two tables as a minimum that have related fields, and you're trying to query data that's related between the two tables without using one of the join statements. Now, before we begin, I just want to say that I'm not showing you this as if to say this is just one really good option that you should know about and use it when you want. I'm not saying that at all. I'm showing you that this is possible, and you may even see examples like this either online or in a SQL book. Sometimes people show this when people are really new just so that they don't have to get into joins and stuff like that. But to make a long story short, although this is possible, you should never query like this because you'll run into a lot of problems. First, I'm going to show you how this works ostensibly. Then I'm going to show you how easy it is to break. And then I'm going to finally show you at the end what you should be doing instead. Okay, so this may take a little while. We have 6 screens to go through, but if you can understand this from start to finish, you'll really benefit from it. Okay, so first of all, these are two tables. One is called employees and the other is called departments. And just really quickly, let's take a look at this. The employee table, has the person's first name, their last name, their salary, their hire date, and then it has a department key. This number hopefully maps to the DP key in this department table. So like for example, this guy Vladimir, who's in department 4, that means that Vladimir, is in department 4, which is IT. So he's one of the cool guys. Okay, so you get it. Notice also that there are 11 people in the employee table, and there are 5 departments. One of the things that you can do in SQL, and this is a really bad idea, but you can do it, is you can say select star from, and then you could just list the two tables, comma delimited, like this. The problem with that, though, is you're not really, even though there's related data, you're not really telling the query what's related from one table to the other. And what it's also going to do is pull every field from each table, so it's going to be a very big query. So notice what it does. It's got everything from all the fields from the employee table and then all the fields from the department table. But also, if you notice, it says that Bubba, this first guy, is in Department 1, Department 2, Department 3, Department 4, Department 5. We know that's not true. Everybody's supposed to be in one department. Here's this guy, Dave Levine. Whoops. Let's pick somebody that... Let's pick this George Morrison fellow. It says that he's in Department 1, 3, 2, 4, and 5, but we see here on his table he's really in Department 5. So any of these records coming back 1, 3, 2, 4, they're not correct. They're not the right information. We actually have not really corrupted, but pseudo information, misleading information. What we've really done here is we've done what's called really like a cross join without even using the word join. We're basically taking all the fields from the one table and sort of multiplying them against all the fields in the other table. So since we had 11 employees and 5 departments, you guessed it, we would have 55 records in this table. That's crazy. There's only 11 employees. Well, let's look at this again. Now I'm just going to take the 3 fields that I want so that we're not taking every field from each table. But you see, we still have the same problem. It's a little easier to look at right now, but see, like for example, this person called some guy, or you may pronounce it Some Gui, but anyway, some guy. Some guy is in every department. Again, we know that that's not true. What's wrong with this? Why would anybody want to query this way? But here's a way to fix that, but it may not be as good as we think. I'm going to select the first name and the last name from the employee table, and then the description or the department from the department table, again from these two tables, but I'm going to put a where clause, sort of like a filter, where it says, but in the DP key in the employee table, this foreign key, has to match up perfectly with the DP key in the departments table. So now we should get a list that's a lot shorter. And there it is, boom. Now, here's the point in the movie where the person says, "It works, we win." Not really. And here's where you have to be careful, because if you're new to databases or if you're setting up a new system of some kind, if you start using queries like this, it will look like everything's working in the beginning. And the reason for that is developers are notorious for putting perfect pieces of information in a system. You'll add an employee and you'll add a DP key that's legitimate. End users, on the other hand, are notorious for getting data into the system that like is impossible and shouldn't work to begin with, and how did they do that? But in any event, it looks okay. I mean, we've got Dave Levine, and we know he's in accounting, check. Pamela Miller, she's in HR, check. All these cool guys are in IT, the developers, like Vladimir, Patesh, Dave, Roy. George is in management, nobody likes him. And then the sales guys, they're great. Tony Macaroni and Kenny Sellum, they're in. So it looks like everything's working, but wait a minute. Don't forget, although this looks beautiful, do you notice something different between these records, there's 9 of them, and these records, there's 11 of them? What happened? Well, you see, in the query with the 2 tables where we did this filter with our no join, these 2 guys didn't show up. Some guy and Bubba Lubba, yeah, I made that name up, he'll probably play for the Cleveland Indians. These 2 guys didn't have a seat at the table. Why is that? Well, because in one case, the person doesn't belong to any department. The DP key is null. Why is that? Who knows? The longer you play around with databases, you'll realize data gets screwed up and corrupted. So you have to think about that ahead of time, as opposed to just creating a perfect set of data when you're just initially building something. And then Bubba Lubba has a -1. That could have just as easily said 15 or 19, but just it might look like a legitimate number, but if there isn't anything in the department table that equals that, it's not going to find anything. So basically what we did by running this query that looks okay, we took 2 of the people and we stranded them. They're not on that list, and that's no good. What could we do? Well, let's go to number 4. We could start goofing around with this and trying to, like, it's broken, but we can try to fix it. So what we're going to do is say, select these 3 fields, again from these 2 tables, where the employee DP key equals the department DP key. Or, either this is true, or at least let's take, or the DP key in the employee table is null. Well, let's watch what happens with that. So we're thinking, well, we know that one of the employees had a null DP key, so instead of getting 9, we're not going to get all 11, but maybe we'll get 10 records, right? Wrong. It looks good so far, but look, we had 14 records. And why did we get 14? Because now we have some guy, and some guy, when we ran our employee table, just the table itself, this fellow called some guy, his DP key is null, right? Okay. But because of that, SQL Server didn't know what to do with him. So he figured, well, if it's null and it doesn't really match this, it is null, but it didn't know which record, if any, from the department table to give him. So it's like, well, let's just be nice and give him everything. So we're kind of back to square one. The query works for these guys, but it doesn't work for some guy. Yeah, it'd be easier to, like, maybe we could just fire one guy, or some guy if, everybody doesn't like him. Like Stapler guy, maybe. Conversely, we could say, what if the, like with the other guy, Bubba Lubba, he has a DP kit that's not in select DP kit from departments. If we run this, then we run into another situation where it's giving us these fake records again because he doesn't have something that matches those in the other field. So it's kind of a situation where every time we try to fix something, we break something else. And there's ways that we could finally get this forced to our will by using things called if exists and select case statements, but by the time we do this, the query is going to look really ugly to do something simple, because we're just trying to do something simple. And anybody else, a developer, a programmer that looks at our code later on, they may not understand why we had to do all that. So what saves the day are joins. I'm going to show you a simple way to join information, which takes a lot of the pain out of it. But when we do this, this still won't solve all of our problems. But notice how nice it is. In this case, all I did is I selected my 3 fields, but instead of saying from employees, comma, departments, I renamed the table EM, and I renamed the renamed this one DP. So when I say inner join, then I say on, this on keyword, and then DP for department, basically the department DP key equals the employee's DP key. And it's very similar to what we were doing over in 4. It's basically very similar to this line. Except that if you notice in this where clause, it has all this, it has this, and forget all the stuff below it. But notice this here, because I'm doing a join, there's no where clause. You don't even need the where clause. Basically, this inner join magically tells the system, it's a where clause where we're saying this key equals that key. But notice, we still only have 9 records. So it still doesn't work. So how could a no join be any better than an inner join? Well, here's the last piece of the puzzle that we have to look at, and it's called a left join. Let me explain what's happening. The way an inner join is basically the same thing as a where clause, saying where the key in the first table equals the key in the second table. Ignore anything else on either side. A left join is a little different. A left join means that one of the tables we want to take everything from, and then in the other table we just want to take records that match it. So in other words, and the reason why it's called left, this would normally be on like one line. SQL Server doesn't look at white space. But if you see these two tables in the from statement, see how there's employees is here and then departments is here? Employees is to the left of departments and departments is to the right. So what that means, it has nothing to do with the order of stuff after the on. All that means is that in this case where there's employees and departments, the left table is employees. So on a left join, we'll be taking everything from employees and only the stuff from departments that matches. So here's the beauty of how that works. We run this, and bam. Now we have all 11 records like we were supposed to have from the beginning of time. The only thing is, there's no department description because these two guys didn't have one that matches. Now, we could do something nice like this and just do an is null. If it's null, just give us something blank, and then we should probably have name the field so it doesn't come back blank, like if it's going to be in a record set or something. And now at least it doesn't say null. But the good thing about this is, even though these two guys don't have departments, they probably do, but just not in the system, they still show up in this record. They should still show up in these results at this record set. So they do get returned, and they only get returned one time, and they're not being assigned to all 5 departments and showing up 5 times apiece. So in order to make that happen, the only thing we had to do is put in left join and then this little on statement. That's it. And it figures everything else out. It gives us just the stuff we want, it matches everything, and when there isn't a match, it knows what to do with it. There's no where clause, there isn't anything where this is null and that's null. It has all that figured out already. It has built into it all of that functionality. So that's why you never, ever, ever, ever want to use here a no join. This is fraught with problems. What you really want to do all the time is use a join, but you have to know which one that you want to use. And in future videos we'll be talking about inner join, left join, right join, and so forth. So I hope that this was helpful.